This time, let's take a closer look at the concept of diffusion. In the past, generative adversarial networks, or GANs, received a massive amount of attention from the community, but now we have largely moved on to diffusion models, haven't we? Way back in 2018, when GANs first started to gain significant popularity, artistic portraits just like this one were created using GANs and were sold for approximately 450 million Korean won. It was officially called the very first portrait ever made by GANs, but looking back, the overall quality was actually quite low. But in 2022, it was revealed that the artwork which won first place in the digital art category at the Colorado State Fair was created with Midjourney, causing a huge sensation in the field of diffusion models. That's because, to the human eye, it's now reached a level where it's hard to tell whether a person or AI created it. In the case of diffusion models, the basic concept is that if you have an original image and gradually add noise to it step by step, eventually it becomes a completely noisy image. So, once you reach a completely noisy state that follows a normal distribution, since you have data of the original image with noise added, you can now go in the reverse direction. You train the model to go in reverse. So by repeatedly removing the noise, you eventually reach the original image. Training this kind of denoising unit is the most fundamental approach. For example, if I want to create a wheel, I start from the wheel design and go all the way to complete noise, then gradually remove the noise from that perfect noise state to restore my original image. And if you add various techniques here, the quality improves even more. So when it comes to stable diffusion, instead of just adding noise to the original image like this, it uses a specific method where a process of dimensionality reduction is performed. Noise is systematically added and then carefully removed within that reduced space. And then the final result is reconstructed and restored back to its original form. So this is essentially a sophisticated methodology that utilizes the power of diffusion within the noise-latent space. Originally, this kind of diffusion process is carried out in the latent space, and that's where the VA model is utilized. And here, you can now add various conditions. So you can use an image as a condition, or you can use text as a condition, and by doing so, stable diffusion enables you to generate the designs you want. If we look at an example of how this is applied in engineering, for instance, in 2D, although bracket data is 3D, you can represent that 3D data as a depth map like this, and then use diffusion to create new designs based on that depth map. Afterward, you can reconstruct the newly generated depth image back into 3D. By doing this, you can bring the advantage of generating high-quality 2D designs using diffusion into engineering applications. Also, if you want to generate directly in 3D, there are studies that combine DeepSDF, which we learned about earlier, with diffusion, as shown here. Now, finally, let's talk about multimodality in the context of generative AI research trends. For example, with ChatGPT, new versions are continuously being developed. It's already up to version 4.0. The advantage of ChatGPT is its multimodality. It can recognize images too. It can also understand text. It can process various types of data. This is the strength of multimodality. If we think about how to utilize these in engineering design, for example, let's say you want to create a vehicle, you could input descriptive information about the vehicle, or 2D or 3D information in the style you want, or even some engineering values as tabular data. Then, by learning through multimodality, it could ultimately generate a design that satisfies all of your requirements. And another significant advantage of this powerful LLM is that it can actually write code, right? So usually when we are using complex CAD or CAE tools, we use software with a graphical user interface. But in reality, absolutely everything inside that system runs on a very deep code base. So if I simply input the specific requirements I want, and the LLM understands them perfectly and expresses them as functional code, then as long as that generated code is properly and seamlessly interfaced with my existing commercial software, the LLM can truly understand what we say and directly control the CAD or CAE software for us in a very efficient way. It almost feels like I'm designing just by speaking. Also, if the model learns existing data well, including manufacturing conditions, then in the case of an idea, I could ask, I want to create this kind of design, how should I do it? Then it could respond, the optimal process for this is CNC machining. And these kinds of things, I can also... When I bring in another specific case, it might proactively suggest something like, for this particular project, you should use water jet cutting. It can propose various manufacturing methods, and furthermore, if I say, okay, then I want to make this design using CNC machining. Can you check if there are any issues? It could potentially respond by saying, there are manufacturing problems in these specific areas, so you should fix them like this. Of course, this doesn't mean the quality is absolutely perfect yet, but this entire workflow can most certainly be utilized in a practical sense. Another important thing is that we really need to consider the critical role of human involvement and oversight. Rather than simply expecting AI to independently generate entirely new, creative, and good things on its own, we should think deeply about how people can collaborate with AI to create even more creative results. For example, if AI generates something, a person could be inspired by it and create a new design, or evaluate whether the design is good or not. In this way, it's absolutely necessary for LLMs and humans to work together iteratively on design.